Hello everyone, welcome to Nevin's Data Lab. In this video, we'll learn about KNN, which stands for K nearest neighbors. This is a classification algorithm. If you haven't watched the other two videos in this channel, in this playlist, I would highly recommend you to watch that first. So let's begin. So KNN stands for K nearest neighbors. So what exactly does it mean? Let's say we have this graph and we can see that there are clearly two clusters. Let's call this cluster A and cluster B, and we want to decide what the blue point, that is this point, which cluster does this belong to. So we can think of a brute force approach, which is basically calculating this the distance between this point to each one of the points of both the clusters. So how we can do that is there are multiple ways, but the three main ways would be either by calculating the Euclidean distance. The other way would be the Manhattan distance. Manhattan distance basically measures the sum of the absolute differences between the coordinate of the points. What does that mean? Let's say this is 0, 0 and this is like 4, 4. So the Manhattan distance would be 4 minus 0 plus 4 minus 0 absolute difference. Yeah, you can understand I can't really write in this. Yeah, so basically the Manhattan distance in this case would be 8. This red line is basically the Euclidean distance, which is the shortest path from A to B. And the next one would be Hamming distance. Hamming distance is basically the number of positions at which the corresponding bits are different. Let's say you want to calculate the Hamming distance between these two, so you'll write them in binary and then check how many bits are different. So in this case we can see that 2 bits are different, so the Hamming distance would be 2. In this case we can see that 3 bits are different, so the Hamming distance would be 3. For this implementation I would be going with the Euclidean distance. So let's start. Like in the previous video, we will move ahead with a structured approach. So let's start by defining classes. We've taken self and the parameter k. Let's set the default value as, let's say, 3. We would also need a fit function. This would take in self comma x comma y, and in the end we would need a predict function. This would need x. Let's just define self dot k is equal to k. The fit function would be self dot x train is equal to x, self dot y train is equal to y, and for the predict function we would require the Euclidean distance, so we can write a function to calculate the Euclidean distance. Distance x1 comma x2, basically we're calculating the distance between these 2 points. This would be np dot square root of np dot sum x1 comma x2 the whole square, and of course you have to import numpy as np. Next we have to write the predict function. So for predict function we have to calculate the distance of x, of individual x, with all the x's. So for small x in x, for x2 in x train, self dot x train, we have to calculate the distance, Euclidean distance between x comma x2, and we can distances start up, and we can just create a list to store all the distances. Also small correction, it is x1 minus x2 the whole square, not x1 comma x2. And to get the k nearest distances, we can use np.argsort. Basically argsort will give the indices of the sorted list. So k indices is equal to, and we'll take the k. Basically this will sort the distance list, and then it will like give the index instead of the value. So that's why I've written k indices, and this will be self dot k. So the k nearest labels would be self dot y train of I for I in k indices, And now we have to calculate the most common label. Why we are doing this is that, for example, let's say these 2 points, I mean these three were the closest three, and for k is equal to 3, let's say these three were the closest points. So which one would we categorize this point into? We would categorize it into the green cluster, because majority of the majority of the 3 points were similar to this point, and only 1 point was similar to this point. So we have to basically take the majority voting. So for calculating the majority votes, we can create a dictionary. Let's say it is the dictionary nearest labels. We can write d of first labels of I 0. First initialize it to 0 and then run the same code is equal to 1. So we get the counts of each of them, and we'll have to sort them. So sorted d is equal to sorted d d dot items key is equal to lambda x2 x1, and we need it in descending order, so reversed is equal to true. And let's just print this sorted d. And for testing this, we'll have to import a data set. So let's import the iris data. So from Sklearn import data sets, and df is equal to datasets dot load iris. So the x comma y values will be df dot data comma df dot target. This is similar to what we did in the previous video, and like in the previous video, we can split the data with 80% in training and 20% in testing. Now let's create this thing, and KNN dot fit x train comma y train, KNN dot predict. This would be x test. Let's see what's the output that we get. Okay, we are getting an error. Okay, so after some debugging, I got to know that there was a bracket missing over here, and also this should be reverse is equal to true, and we will also just return. Okay, wait, and this whole thing should actually be inside this loop, and let's say predictions is equal to thing. Distances will go inside this, and predictions start append sorted d of 0 0. Basically we are taking the most occurring label, and we can just return predictions. Let's see if this works. As you can see, it is working. I mean, it's not throwing any errors right now, but we are not able to because we haven't printed anything. Let's just print this and then run it. So you can see that now we are at least getting some predictions, so we are moving in the right track. And to get the accuracy, we can check from our previous code. We can just copy that, and we can is equal to this print accuracy of y test. And okay, pred is first, so pred comma y test. Let's run it and check. So you're getting like 76% accuracy. So if let's check if we change the value of k to 5, we'll get any differences. So you can see we are getting 80% accuracy. So that's it for the KNN model. If you have any questions, please leave them in the comment section below. Thank you so much for watching.